Assalamualaikum and very good morning to madam. My name is Muhammad Faiz Fitri bin Abdul Rahim. My metric number is H20A1271. Today I will present part A, number 1. In appendix, I took 50 random sample to describe the data. So n equal to 50, which is n should be greater than 50. So 2 power of k is greater than 50, which is the formula. And after we try a few number of seeds is greater than 50, therefore we can say that the class for this dataset is seeds, which is greater than 50. So in my data class width is 308.3 minus 209.7 by 6 that equal to 90.4 that I run up to 17. This is my table class and frequency. Here set the individual class. We need the minimum data entry is convenience lower limit for the first class and add to class width of 17 to the lower limit each previous class. For example, minimum data 209.7 at 17 to 226.7. The upper limit for the first class is 225.7, which is one less than lower limit of the second class. The upper limit of the other class are 242.7 at 17 equal to 259.7, and the frequency is 2, 3, 6, 10, 18 and 11, and when I total it, I got 50 frequency. The next is class frequency, relative frequency and cumulative frequency. So the formula relative frequency is class frequency divided by sample size. Sample size is 50, and then frequency 2 is divided to 50 equal to 0.04, and the next is 0.06, 0.12, 0.02, 0.36, 0.22, and the total for relative frequency is 1. And the formula for cumulative frequency is cumulative frequency of the last class is equal to sample size. The first cumulative frequency is 2 and has to add with frequency equal to 5, and the next cumulative frequency is 11, 21, 39 and 50.
For graphical method, we construct a table which have a class lower boundaries, upper boundaries, midpoint and frequency. So for the first graph, it will be 6 class for each categories. So based on graph 1, we can conclude that the highest frequency 18 with a midpoint of 285.7, while the lowest frequency is 2 with a midpoint of 217.7. While for the second graph, we use the same method, which is construct a table which have a class, upper class, boundaries, frequency, cumulative frequency, and there are 6 class for each categories as well as the first table. Based on graph 2, we can conclude that the shape of the OGIF graph is increasing.
Thank you from the previous presenter. Assalamualaikum and a very good day to everyone. My name is Erina Yasmin binti Muhammad Rosli and my metric number is H20B1888. So today I'm going to present about measures of central tendency. Okay, what is measures of central tendency? Well, it is a value that represents the center of distribution. There are 3 most commonly used, which is mean, median and mode. Okay, for mean section, this is the set of data. We have classes, frequency, midpoint, and fx. Okay, how do we get fx? Well, it is a total of frequency multiplied with midpoint. Okay, and here is the solution. Fx divided by n. So the last calculation is 13,809 divided by 50. So the answer for mean is 270 6.18. Okay, how do we find the median part? Well, we need to have three tables, which is classes, frequency, and cumulative frequency. And then n must be divided by 2. So we got the observation answer, which is 25 when 50 divided by 2. When we look at the table, the closest number to 25 in cumulative frequency is 21. It is automatically the median class, which is 260.7 until 276.7. So for the solution, we took the LM, which is the lower boundaries, which is 260.7 plus, in bracket, 50 divided by 2 minus 21 divided by 10 times 17. So the median that we have here is 267. In mood part, they only consist of two tables, which is classes and frequency. First, we need to see the highest data in frequency, which is 18. And then take a look at the lower class, which is 277.7. To get a lower model class, 277.7 minus with 0.5, and the answer is 277.2. And here is the solution, and the final calculation for mood is 283.6.
Measures of variation in terms of range. Range was used to find between the maximum and minimum data entry in the set. The formula measure range. Range equal to maximum data entry minus minimum data entry. So for this data set, range equal to 308.3 minus 209.7 equal to 98.6. Therefore, the range of the current price of bungalow for a given size square feet in Kuala Kra, Kelantan is about 98.6. This is variance formula. In this table, they have column of classes, frequency, midpoint, fx, x power of 2, and lastly, fx power of 2. How do we get fx number? It is a total of frequency multiplied with midpoint. So, the sum of all in the fx column is 13809. To get the answer for x power of 2, midpoint must be multiplied within 2 times. Lastly, the column of fx power of 2, we need to take midpoint x power of 2 values times with frequency. The total values in the frequency x power of 2 column will be 3839294.1. This is the solution for variance. The first thing is 1 must divided by 15, and then 50 must be minus with 1. So the answer is 1 divided by 49 in bracket 38394.1 minus 3813,769.62. The answer is 520.9, and for the standard deviation is about 22.8.
To determine the measurement of position, the data must be sorted from lowest to highest. In this topic, we focus on quartile. A quartile is a set of data will be divided into 4 groups. Each quartile contains of 25% of the total observations. The first quartile is the lowest 25% of numbers, and the second quartile between 0% and 50% up to the median, and then the third quartile, which is 0% to 75%, and the last quartile is the highest 25% of numbers. Okay, from this table, we need to take a look at the column of the current price, which is classes, and then frequency, and then cumulative frequency. Okay, the first step in quartile 1 is find the location of quartile 1. So n must be divided by 4, which is 50 divided by 4 equal to 12.5. And the class interval is 226.7 until 242.7. So the step 2 is take the lower boundaries in class interval, which is 226.7, must be minus with 0.5, and the answer is 226.2. And the F is the frequency, which is 2, and then the frequency quartile 1 is 3, meanwhile class width is 17. So the solution for this quartile 1 is 226.2 plus in bracket 50 divided by 4 minus 2, and then divided by 3, close bracket, and times with 17. So the answer for quartile 1 is 285.7. For quartile 3, the first step is find the location, which is 3, and n is 50, and must be divided by 4. So the answer is 3 in bracket 50 divided by 4 equal to 37.5. So the class interval is 260.7 until 276.7. So we take a look at the lower boundaries, which is 260.7 minus with 0.5, and the answer is 260.2. For the solution, 260.2 plus in bracket 150 divided by 4 minus with 11, and then divided by 10, and then close bracket times with 17. So the final answer for the quartile 3 is 305.25. In interquartile range, we take the answer for quartile 3 minus with quartile 1. For example, 35.25 minus with 285.7, and the final answer for interquartile range is 19.55. This is the shape of data distribution of the current price of bungalows in Kuala Krai, Kelantan. Mean is 276.18, median is 267, and then mode is 286.3. So that is mean is greater than median, and the median is lower than mode. Therefore, it is skewed to the left. That's all from me and my fellow friends from the part A, and I'm gonna pass to the next presenter, which is part B. Thank you.
Hi, my name is Samiha binti Shahrudin. My metric number is H20203. Part B, question 1. Find one set of data that have one independent variable and one dependent variable. This data have one independent variable, which is age, and one dependent variable, which is body mass index BMI. A researcher wanted to see if there was a relationship between age and body mass index BMI of the people in the world. A total of 30 people were randomly selected from the BMI list for the rest of the year. The data below indicates 30 random age was selected with different BMI for each age in order to complete this report. This data sourced from ResearchGate with title Information According to Age and Body Mass Index BMI.
So we move to the number 2. If the data set consists of n more than 100, then you may select at random. N not greater than 100, but n must be at least 30. This dataset is n equal 30, as you can see in the previous slide that indicates the 30 sample of data.
In statistics, the Pearson correlation coefficient, also known as Pearson R, the Pearson product movement correlation coefficient, the Beverly correlation, or colloquially simplified as correlation coefficient, is a measure of linear correlation between two sets of data. In this video, we are going to talk about how to calculate the correlation coefficient. Now, let me see the table of correlation coefficient, and we have construct movement to get the final answer to correlation. Okay, so we can look the data on the table. The value is going to be plus 1 by 1, and the total is x, sum x, 807, total for y, sum y, 811.3, total for x square, sum x square, 26,639, total for y square is sum y square, 2,776.95, and the last one sum xy 23,089. Look at the formula. The formula of correlation coefficient is R equals sum of xy minus sum x of times sum of y divided square root of bracket y power of 2 divided n. The final answer is 0.122. There is very weak positive correlation at 0.122 between x and y. That's all from me. Thank you.
Hi, my name is Farah Adila Binti Jafri. My metric number is H20A1140. Today I will present question 4 for part B, which is simple linear regression. Refer to the question is estimate regression equation and interpret the regression equation. Estimate regression equation, the formula is B1 equals sum xy minus sum x sum y divide with n. Divide with square root bracket sum x power of 2 minus bracket sum x bracket power of 2 and divide with n. So this is how we calculate by using the formula is B1 equal 23,089 minus 847 bracket with 811.3 bracket divide with 30 and square root bracket 26,639 minus bracket with 847 bracket power of 2 divide with 30, and we will get the answer is 0.067. And next formula is B0 equal y bar minus B1 x bar, and the calculate is 27.04 bracket with 0.067 multiplication 28.223 bracket, and we will get the answer is 20. Next is interpret the regression equation. The formula we using is y bar equal 25.15 minus with 0.067x, and the slope is B1 equal 0.067. So for every age and body mass index of people, the number of BMI will increase about 0.067, and the constant is B0 equal 25.15, and when the age is 0, the number of BMI is 25.15.